Welcome to Direct Variation. Today's objective is to identify, write, and graph direct variations. So within the context of linear functions, there are some different types of linear relationships we've seen so far. And one of them that we're going to study today is direct variation. And direct variation is a special type of linear relationship that can be written in the following form, which is y equals k times x. So k is going to always be a non-constant zero, and that we call it the constant of variation. So for example, if we had the equation y equals 5x, we say that y varies directly with x. So say y varies directly with x. And there are many examples of two items that vary directly with each other. For example, if you have a job that pays by the hour, the amount of money that you make varies directly with the number of hours that you work. So, for example, you could say that someone's making $8 an hour. So this could be a direct variation equation where we say that y, or the amount of money that you make total, varies directly with the amount of hours that you work. So this is one example of a direct variation equation. Let's look at some examples of different linear equations and determine if they can represent a direct variation. And if they can, let's identify the constant of variation. So for example A, we have y equals 4x. And you can see that this falls into our form of y equals kx. So this equation can represent direct variation, and the constant of variation, so we'll call that the COV, here is 4. Okay, let's look at example B. Now example B on the surface looks like a standard form equation, but let's see if we can isolate y. So if I added 3x to both sides, I would have 5y equals positive 3x. Then I would divide both sides by 5, and what I would be left with is y equals 3/5 x, which you can see falls into the format of our direct variation equation. So this is also a direct variation with a constant of variation being 3/5. So be careful to judge it on the surface. Always try to isolate y, and that'll give you your result, and it'll tell you if it can be a direct variation. Alright, let's look at example C. So in example C, it seems to be written in standard form, so let's try to isolate y and see if anything happens. So we'll subtract 2x from both sides, and we'll be left with y equals negative 2x plus 10. Now this plus 10 tells us that it's not a direct variation. There's something else involved in this linear equation. So we would say not direct variation. So the key step for determining if an equation can be in direct variation is to isolate y and see if it falls in the formula of y equals k times x. Let's say that you're given a set of data and you're asked to tell whether the relationship is a direct variation. So what you want to do is see if each ordered pair has a similar constant of variation. So what's the constant of variation? Well, we start off with this equation, y equals k times x. We remember that k is the constant of variation. So we want to figure out if each of these ordered pairs have the same k. So to do that, let's isolate k by dividing both sides by x. So to find the constant of variation, what we have to find is y divided by x. This is what we're going to look for in each ordered pair. And if it's the same throughout the whole set, then we know that the relationship is a direct variation. So if we look at our data points here, our first one is 6 over 1. That equals 6. Our next y over x is 18 over 3. That equals 6. And our last one is 30 over 5. And that equals 6. So, since each ordered pair has the same constant of variation, we say that the relationship is a directed variation. Okay, let's try example B. So let's use our same method. Let's see if each ordered pair has the same constant of variation. So look at my first ordered pair, and I'll do the y over the x. That gives me -1. Then I'll do 0 over 4, and we know that that is 0. So already we can see that this is not going to be a direct variation. We can keep going, and we see that we have 4 over 8, and that's 1/2. So none of these are the same. Therefore, the relationship is not a direct variation. So we'll write not direct variation. And the reason is because these three ordered pairs have a different constant of variation. Let's look at an example of graphing direct variations. So we're going to look at the three-toed sloth, who is an extremely slow animal. On the ground, he travels at about 6 feet per minute. So we're going to take this information, turn it into a direct variation equation, and then graph it. So our variables here are the amount of time the sloth travels and the distance. We know the rate. So we can write this as y equals 6 times x. There's our direct variation equation. It follows the format of y equals k times x. So now we just want to graph this. So we can make an x and y table. And we know that he can't go back in time, so our starting point can be 0. We can use the point 4, and we can use 10. At the beginning, he's obviously not traveling any distance. 4 minutes in, he'll travel about 24, and 10 minutes in, he's at 60. So we can just do the positive quadrants. We can use the x values. We're going to go up to 10, so we'll put 10 over here. We'll do halfway 5, and we'll do 4 here as well. And our y values will go up to 60. So we'll do half of 60 is 30, and 24 is right under that. So we know at 0 seconds, minutes, hours, he's right at the origin. At 4 minutes, he's at 24 feet. And then at 10 minutes, he is at 60 feet. So our linear equation, which is also a direct variation equation, is shown now on this graph. So let's look at an example where we have to find a value of y given a value of x in the context of a direct variation equation that we know is happening. So here in this problem, the value of y varies directly with x. So we already know this is a direct variation problem. And we know that when y equals 6, x equals 12. So we are finding the value of y within that same direct variation. So we know that the constant of variation is going to be the same. So to solve these, what you want to do is set up a proportion. Now the reason this works is because all of the values of y over x are going to be the same. So if we set up a ratio with these two values, we'll be able to set up a ratio with these two values, equal them to each other, and have our proportion. So we're going to have our 6 over 12 equal our y over 27. So our first step was to set up a proportion. Then we cross multiply and solve for y. Okay, so we multiply the 6 times the 27 and get a value of 162, and that has to equal 12y. So here we just solve for y, divide both sides by 12. Y is going to equal 13.5. And that's how we solve for the value of a missing ordered pair when we know that we have a direct variation equation. Alright, that's going to be the end of our video for today. Thank you for watching, and I hope this was helpful. Take care.